Hey, what's going on, guys? Today we're going to be talking about PWM, or pulse width modulation. I don't know if you guys have ever heard the term or been scrolling through some wiring diagrams and see on the wiring diagram that a circuit has PWM. Well, PWM stands for pulse width modulation. So PWM is the acronym. Pulse width modulation is what it stands for. So pulse width modulation is used in fuel injectors, ignition coils, fuel injectors, boost control solenoids. Also, some Hyundais use it on a cooling system. The cooling fan utilizes PWM. So we'll use a fuel injector, for example. So we all know that fuel injectors pulse. They don't stay wide open, constantly spraying fuel. They pulse according to load by RPM. So usually that's the way that a engine control module is set up. You can't see these tables, but you'll have load versus RPM, and then you'll have cells, load cells. So depending on how much load versus how much RPM the engine is calculating, it's gonna adjust your pulse width accordingly. That way the engine air-fuel mixture is proper for proper performance. So all pulse width modulation is the controlling of current flow on and off. So we'll say a fuel injector has two wires, power and ground, or positive, negative. So the fuel injector, the way that it's controlled to constantly go on and off is pulse width modulation, meaning that you don't have a constant power. You'll have a constant ground, more than likely to the PCM, but your power is going to be pulsed. That way it creates a on and off spraying effect of the fuel injector. And to test PWM, you can't use a regular meter. A regular DVOM is too lazy or too slow. So the DVOM will only see, for example, 3.18 volts. And the voltage will fluctuate slightly. But to properly test a PWM system, you will need an oscilloscope or O-scope. An oscilloscope is fast enough to pick up the waveform. So when using an O-scope or oscilloscope, if you're back probing a PWM system, your waveform should be something like this. So this is your pulse width. So the bottom would be 0 volts or percentage, and then your on time would be in seconds or milliseconds. So we'll say 10 milliseconds, 10 milliseconds. So every time this waveform is created, it's commanding the fuel injector to come on for 10 milliseconds. So that's faster than me and you can process. And also the DVOM can't process that, but an oscilloscope will pick up that waveform. Another example of a PWM component on a vehicle is a purge valve. I don't know if you've ever heard of the purge valve in action, but it doesn't just open and stay open. You actually hear it clicking on and off, on and off, on and off. So the computer is pulsing that purge valve on and off. in order to suck the vapors from the charcoal canister back into the intake manifold. If the purge valve was to just stay stuck open, then it would be creating too much vacuum in the tank, possibly bringing in raw fuel or liquid fuel into the canister or to the engine, causing stalling, rich conditions, something like that. So back to we're still talking fuel injector. So at idle, we're gonna say our PWM is 10 milliseconds because we're at idle. If you do a wide open throttle snap, then your waveform should pick up, and your on time of the fuel injector, we'll just say 40 milliseconds, is going to increase due to the higher load of the vehicle. The oxygen sensors are seeing more oxygen, so there needs to be more on time for the fuel injectors. And then for the cooling fan systems, most of the newer vehicles do have a PWM wire. So your cooling fan is going to be usually 3 pins. So you have your negative, your positive. These 2 pins are always a big gauge due to the amount of amps that the cooling fan is going to be pulling. And in the center, you're going to have a small PWM pin. So the theory behind that makes sense to me is this is your connector, and then you have your cooling fan motor. So the theory behind that to me is they do that to control the fan speed. Everything is trying to target better fuel economy these days. So if your cooling fan was just getting direct power, then that fan's going to be spinning at full speed, creating a bigger draw on the battery, creating a bigger drag on the alternator, lowering your MPG. So with pulse width modulation, if the way that the computer looks, if you go to your live data, you'll have fan PWM, and usually 10% the fan is going real slow. The fan will be spinning real slow, and then as the vehicle gets to like 210 degrees, then your cooling fan will kick on higher, but your PWM will only go to 40%. So like I said, it's to control the fan speed. You don't need constant power going to it. I guess it's easier to control it this way. And once you turn on your AC, you'll probably see 80% PWM or pulse width modulation, and then your fan speed goes up even higher due to the AC being on. And then when checking the PWM for a cooling fan, as your pulse width modulation goes up on a voltmeter, your voltage would just go up. But like I said, if you use a DVOM, if you use an oscilloscope, you should see a waveform. This would be 10% fan duty. This will be 40% fan duty. And then this would be 80% fan duty cycle. Like I said, you need an oscilloscope to be able to actually see this and actually properly test it. But if you do have a meter, you'll at least see some voltage on the meter. So at 10%, you'll probably be let's just say 3.5 volts, 40%, your voltage will go up to 5 volts. And then 80%, we'll say 7 volts. So you could still use a DVOM to make sure that there's actually something going to the PWM wire. And then that's new school, old school stuff that most cars have now is ABS. So ABS is one of the main systems in the vehicle that uses PWM. So the ABS stands for anti-lock brake system, obviously. ABS, anti-lock brake system. So before ABS was created, so a vehicle with no ABS, if you're going down the street and all of a sudden you need to lay onto your brakes, the front tires are just going to lock up because all the brake pressure, right? If the tires lock up, the vehicle will slide, you get into an accident. So that's why they came out with ABS, or anti-lock brake system. So the way that the ABS system works is the ABS pump, if it gets activated due to a sudden brake event, the ABS pump is going to send a pulse width modulation out and brake fluid pressure. So since the vehicle is pulsing the ABS module, now your front tires aren't going to be under full pressure, and in turn you're not going to lock up the front tires and smash into a car. If you've ever activated the ABS system on a vehicle by slamming on the brakes, if you haven't done it, go out and use a vehicle that has it. Lay on the front brakes or lay on the brake pedal and wait for the ABS to kick on, and you will feel and hear the pulse width modulation through the brake pedal. And the front tires aren't going to lock up. They might chirp a little bit for a second, but the computer, the ABS module, is going to utilize your wheel speed sensors. Wheel speed sensor. So the ABS module does watch your wheel speeds. If it sees that you're laying on the brake and your two front wheels, say your rear wheels are traveling at 50 miles per hour, and then the ABS module suddenly sees the front wheels go to 20 miles per hour. Now the ABS module knows that you're laying on the brake and those tires are slowing down much faster than the rear tires. Then the ABS module is going to control that by pulsing brake fluid pressure to your calipers. So I do recommend, just so you guys get an idea of how it sounds and actually feel it, and everything will come together if you take a vehicle out in a safe place, get it up to like 45 miles an hour and lay on the brake pedal, and you will hear the ABS kick on, and you're going to hear an audible on and off, on and off, on and off, and you'll feel it in the brake pedal as well. I hope this video helps you guys out a little bit. Hopefully it makes sense to you guys, and we'll catch you on the next one. Peace.